Hello everyone, this is the follow-up lesson to our methods of solution, part of Unit 7, Algorithm Design and Problem Solving. This includes totaling, counting, finding the maximum, minimum and average value. So we've already looked at these algorithms using all of our previous knowledge of pseudocode so far, putting it all together to use these algorithms so that we're able to identify and solve problems at an even higher level. In today's lesson, we are just looking at the final two here. That is number 1, a linear search, and number 2, a bubble sort. So these are the final methods of solution, the standard methods, and we should be becoming very familiar of pseudocode and all of the techniques that we've looked at so far to do with programming. So before we look at the pseudocode for each of these methods, we need to understand what they both are. Starting with the linear search, a linear search is literally a searching algorithm that searches for a specific item. So if your program needs to look for something within a list or an array, then a linear search might be the one that you use. Now, how a linear search works is it checks each item one by one. So it goes through the list one by one in a linear fashion. So the word linear just means in a line. It looks at each item in the list one at a time and checks if it matches the value that you're looking for. So remember, it's a searching algorithm, which means that we're going to be searching for a specific item. So in our example, we might be looking for a specific name in a list of students. As you can see here, we've got an array, we've got a list of students containing 10 different names of students that might be in a class. Now let's say we're looking for Noah in this list. The first thing we do is look at the first item, which is Ethan, and we check if it equals Noah. Is Ethan equal to Noah? The answer is simply no, so we go to the next item. Is this Noah? No, it's Sophia. We move on and we keep repeating until, as you might have guessed, the search matches the item in the list. So here we found Noah and we found it in position 1, 2, 3, 4, 5. So because we're going through each item one by one, our list does not have to be sorted in any way, whether it's alphabetically or increasing in values if it was numbers. It doesn't have to be sorted at all. Because it's going through one by one, if the thing we're searching for is in the list, it will be found no matter what, because we are literally going from the first one all the way to the last item in the list. So now what we need to do is use our knowledge of pseudocode that we've built up until this lesson and use some of the techniques to create a linear search algorithm, as you can see in this example here. So what we'll do, we're going to use the exact same list as before. We've created an array called names. So names is just a list of items and it contains the same names as before. Then we're going to take an input. So we ask the user to put in a search item and we store it in the variable search item. So in this case, if we just search for the same name as previous, which was Noah, and this is stored inside the variable search item. Then what we do, we use a for loop, which is a count controlled loop, which again we've looked at before, and this loop will run from position 1 to the length of names. Remember, length will take the list, in this case it's called names, and it will give us a number for the amount of items in the list. So in this case we had 10 names, so this is the exact same thing as saying from 1 to 10. So we're going to loop 10 times, starting in position 1. Then when we go into the loop, we check if names position I, so I is currently 1, because this is the first time the loop is going to run, and we're checking if this position equals our search item. Now if you remember, our search item is Noah, and we're checking if the item inside matches Noah, which in this case it's Ethan, so it doesn't. So this line of code isn't run. Okay, this only runs if this condition was true. So if the name matched our search item, then we would have output search item found. We end the if, we go to the next I, so we go to position 2, which is here, and we check if the name matches. Does Sophia match? No, so we do not output search item found. Next I becomes 3, which is now Liam, no match found. Next item 4, we check Eva, no match. And then finally, Noah is found in position 5. So this would output search item found, but in this case what would happen, the loop would continue all the way until it reaches number 10 at the end. But obviously Noah is only in this list once, so it would only output search item found once. If there was a Noah again in this list, so if Noah was here as well in position 9, the search item found message here would have been output again when it reached position 9. So just bear that in mind, that this loop will continue to run as it's running for the length of the list of names. If we wanted to, we could have ended the loop as soon as the search item was found, but that would require using a Boolean value, which we haven't covered yet in the course, so we will come back to this in Unit 8. For now, I just want you to understand what a linear search is and how it works. The next standard method is a bubble sort. Rather than a searching algorithm, this is known as a sorting algorithm. So this isn't an algorithm used to search for a piece of data, it's used to sort a list of items. For example, if we want to change a list into alphabetical order, we could use a bubble sort to do that. Or likewise, we could change a list of numbers from lowest to highest or highest to lowest. There are many sorting methods that exist in computer science, but for iGCSE and for our syllabus, we only need to worry about the bubble sort. And how a bubble sort works is it simply compares each item in a list with the one next to it and swaps them if they're not in order. So it starts at the beginning, goes up one by one, checking if the item next to it is bigger or smaller, and depending on which way we want to sort it, we'll change them around according to the lowest to highest or highest to lowest, for example. So again, we'll go through the theory first before we put it into practice using pseudocode. And in this example, let's say we want to sort a list of numbers here, where we have 8 numbers, and we want to put them in order of size so that the smallest is at the beginning and the biggest is at the end. So going through our list of instructions here, starting from the first bullet point, we'll run through the steps of how a bubble sort works in order to sort it in this order of smallest to largest. So first things first, we start with the leftmost item. So we look at this item, number 9, and we compare it with the one next to it. So the one next to it is number 5, and because we're putting this in order of smallest to largest, we need to see if it's in this order. So if 9 needs to be swapped in 5. So we're checking if the one next to it is less. So is 5 less than 9? If it is, then we need to change. Okay, so we need to put 5 here. 9 then goes here, and we've done our first swap. We then stick with the number 9. So let me just put these in so we can imagine it. So we'll put 9 here instead, and then we check if 9 needs to change with 4, which it does. So 4 goes here, and then 9 goes there. We then check if 9 is bigger than the next one, so 15. In this case, 15 is bigger than 9, so this stays here, and 9 stays there. So we're still in this position, but now we're going to be checking if 15 is bigger than the 3 or not, which it is. So 15 needs to go here, and 3 needs to go here. It keeps going, 15 goes here, 8 goes here, again 15 goes here, and 11 goes there, so we've got 15, and then finally 15 needs to go there because it's bigger than 2, and 2 ends up here. So sorry for the absolute mess I've made there, but as you can see, 15 has ended at the end of the list. So the first time you run through a bubble sort, the biggest item should be at the end. Even though number 9 was being changed at the beginning, once we reached 15, 9 was left where it was, and 15 was then bubbled to the end of the list. Now, as you can see, 9 stopped here, but 9 is bigger than 3, 8, and also 2, so it's still not in order. So if you can already imagine, we need to then go back and do this whole thing again. So here, we're missing an instruction, and this instruction is to repeat the process until all items are sorted. So what we'll do is we'll go through the whole process now, and we can see how this list will eventually be sorted from smallest to biggest. So as you can see, this is the first pass, what we've just done. So this is the first time the bubble sort runs. And as we said, the 9 is swapped up until this stage, and then we start to swap the 15. So the 15 ends up at the end. So orange indicates a number that is in its correct position. And as we said, in the first pass, the biggest number in the list will end up at the end. The same thing applies if we're doing A to Z. We simply check if the word begins with the letter before or after in the alphabet. So A to Z works in the exact same way, except it's checking for alphabetically. Okay, so in the next pass, in the second pass, what will happen is we go back to the first position and we check it against the next number. So as you can see, 4 and 5 needed swapping. We then check 5 and 9, and as we can see, they stay in the same position. Then we check 9 and 3, they needed swapping. 9 and 8 also needed swapping. 9 and 11 stay where they are, however 11 and 2 needed swapping. 11 cannot be bigger than the last number because 15 is the biggest number in the list. So now 11 is now sorted, and as we said, we've coloured it orange just to confirm. Again, we repeat the process, and what I've done is I've left the second pass in just for reference, but you can see here, here's the third pass, and all we need to do is start from the beginning, bubbling up, checking the position of each unit compared to the one next to it. So 4 and 5 already in order. 5 and 3 obviously need swapping, so they are changed here. 5 and 8 already in order, they stay the same. 8 and 9 stays the same. 9 and 2 need swapping. So now 9 is in the correct position. So as you can see, these three numbers here are all finalized in their final position. And each time we complete a pass, the amount of times that we loop is reduced by 1. If we just go back to our original first pass, the loop iterated 1, 2, 3, 4, 5, 6, 7, 8 times. In the second pass, it was 1, 2, 3, 4, 5, 6, 7. And in the third pass, 1, 2, 3, 4, 5, 6. So as you can imagine, these passes will reduce all the way up until there is one pass left. So each pass, the amount of times we go through the list will be reduced by 1. So obviously in the fourth pass, we've only got 1, 2, 3, 4, and 5 passes. And as you can see, 3 and 4 already in order, 4 and 5 already in order, 5 and 8 also in order, and it's just this 2 here. So we need to bubble this 2 down to the beginning because 3, 4, and 5 and 8 are already in the correct order. So again, we just keep doing the process, guys. And here 8 is in the correct position. Finally, 1, 2, 3, 4 iterations. And this time the 5 is going to get put in the correct position, and so on and so forth. The list is finally sorted on the 8th pass, which means that the bubble sort looped for as many times as it has elements in its list. So now hopefully you understand how bubble sort works in theory. All we need to do now is apply our pseudocode knowledge and understand how we write this using pseudocode. So a couple of things I've done here is I've created 2 variables which indicate the first and last positions of the array. So here I've got first set to 1, which is simple because we're going to start in the first position, and last I'm going to set to the length of the numbers, and I'll come back to this shortly. So basically we've got a numbers array. Let me just draw it in so we can see. Okay, so we've got 5 digits in our list. So last is set to the length of numbers. Our list here called numbers has 5 items inside, so last is essentially set to 5. Then we've got here 2 loops. We've got a repeat until loop on the outside, and then inside we've got a for loop. Okay, so we've got a post condition loop here, because this checks for the condition after the loop, and we've also got a count controlled loop here. Okay, so that's just going back over some of the keywords from the previous lesson. Now the first thing I do in the repeat loop is I've created another variable here called swap, and I've set this to false. Now we've not discussed Boolean in detail yet. A Boolean value simply stores true or false. And this variable swap I'm going to set to false at the very beginning. And again, I'll come back to that later on in the algorithm. Then I've got a for loop which is going to run from first, which is 1, to last minus 1. So this is going to run till 4. So index is going to be set to 1 on the first run, but I'm only going to loop until I reach the number 4. Now the reason being is that because I know I've got 5 digits in my array, I'm actually comparing the first digit to 4 values. So the first time the loop runs through, the biggest number is going to be at the end, like I've already said. So we actually minus 1 from the amount of times that we loop. Okay, and as we go through, we'll come back and I'll explain again about that. But again, this is just one of the things that you need to look out for in a bubble sort. So the first thing we do is check if the number in the position index, which is 1, so the number here is 15, we're checking if it's more than the number in position index plus 1. So index is currently 1, and 1 plus 1 equals 2. So that means we're going to check in index position 2. So this line here literally means check the 2 numbers in the 2 positions. And this is what we call our bubble. So we're checking the numbers within this bubble. So the index plus 1 is where students always get confused, but it's literally just referring to the position of the index in the next space along. So it's comparing the number that you're at in the index with the one next to it to the right. That's all that plus 1 means. So as the index goes up, so is index plus 1, and that's again where students can get mixed up. So in this case, we're just comparing the 2 indexes, 1 and 2, which is 15 and 3. If it's bigger, which it is because we've got 15 and 3, then we go into this condition here and we set a temp variable to the number's position index. So let's just make a note of what's going on up here. So a temp variable is going to contain the number from position index. Now index is position 1, and if we take that number, which is 15, we're going to put temp as 15. Then we go to the next line, and numbers index, again, index is still 1, it hasn't changed. We're going to put inside there the number from numbers index plus 1. This is where the swap happens, because I take the number from this position, which is 3, and I put it in the original index, which is 1, which goes here. Okay, so this 15 is gone, and it's overwritten by the number 3. So the 3 is now in position 1 there. Okay, so that's the first part of the swap. Then what we do on this line, numbers index position 1. So index is still 1 plus 1, so that's 2. In the index position 2, which is where 3 was, I then set to the temp. Now if we think back here, temp contains 15. So I put 15 in the index plus 1, so here. So this becomes 15. So I've took the 3 and the 15 and I've swapped them round. So these 3 lines of code makes it really easy to identify a bubble sort. That's where the actual swap takes place for the bubble sort, these 3 lines. And simply by spotting these 3 lines of code in the algorithm will help you identify the bubble sort, and that might help you again just know what's going on in the exam. Or the question might simply be, identify the algorithm that you can see here. You'll see these 3 lines and you'll go, I know that's a bubble sort. So then what we finally do here, the swap variable from the beginning, which we set to false, we then change that to true. Okay, so it's now become true because we've swapped a number in this loop. Okay, within this for loop, we swapped a number. So we had to make a note of that, and I'll explain why in a little while. We end the if and we go to the next index. So then we go to index 2, which is here. And then we are simply comparing index 2 to index 2 plus 1, which is 3. So we repeat the whole process and compare the values in 2 and 3. And again, if it's bigger than in this condition here, we swap them. If it's not, we just simply skip to the next index. We keep going and we stop, like we said, once the biggest number gets to the end of the list in the first pass. So within this loop, we changed swap to true because we swapped numbers. Then what we do is our last position that we set at the beginning, we minus 1. So we take our 5 and we minus 1 and it's now 4. So last is now number 4 because the last position was here, but now that 15's in the right place, last is now here. This is where we need to sort up to now because the last position is already done. 15's in place. In our previous example, it turned orange. So minusing 1 from the last position is very important. Now what this loop does on the outside, the until swap equals false or last equals first, this is going to check when either the first condition means that it's all in order or last equals first. Because last is minusing 1 each time here, as you can imagine, this will stop once 4 equals 1, which means it would have gone through all the passes that we've previously mentioned and we would have bubbled through the right amount of times. So there's 2 ways in which this loop can stop. Either we've bubbled through the right amount of times, which is this one, or swap still being false means that this if statement wasn't met, and it means that the list is already in order. So this is probably the most confusing one here, because if we think back, swap is set to true only when the items are out of order. If they were in order in the first place, swap would have stayed false at the beginning, and we wouldn't have needed to have looped through again and again and again. So until swap equals false, we'll also check if the list is in order. If you didn't include this one here, and this check here, and this line here, then it's not the end of the world. The loop would simply loop through every single pass. But what we can do with these 3 lines I've just gotten rid of, it could reduce the amount of times the loop runs if we only needed to change one number's position, for example. Or the list might already be in order in the first place, and we didn't need to change anything. These 3 lines, guys, these are the most important to identify a bubble sort. All the rest, if you can remember that, then fantastic. But even if it's just a case of memorizing this code, then that's absolutely fine, because at the end of the day, this is a standard method that you need to be able to recall in your paper 2 exam. And as always, some questions to finish off, putting into practice exactly what we've been discussing in this lesson. So the first one we'll do is a linear search, and what I've done is include some extra features and techniques that I've discussed in this lesson, and I'll explain in more detail how I've done that during this question. So give the video a pause, have a go at it, and then resume to see the solution. I've created a variable called names, and inside we've got a list of 5 names. We've got Ali, Ben, Chen, Dina, and Eva. So these 5 names are stored in the array or the list called names. I then take an input, and I'm going to save this in the variable target here. So target is a variable that takes in the user input, and it's the name that I want to search for. I've also created a variable which is going to store a Boolean value, which means it can only be true or false. I'm going to set it to false at the very beginning, and I'll explain why shortly. We then go into our for loop, and we're going to run from 0 to 4 as the index indicates 0, 1, 2, 3, and 4 in our array. If you put 1 to 5 and number them 1 to 5 in the index, that's fine. But in this case, I've started from 0 and I run up to the index number 4. Likewise, what I could have done is I could have used the length function. If you spotted this, well done. And I could have said the length of names. Names should have a lowercase n, and that will run to whatever length the names is. This would have also worked, but in this case I've just ran until index equals 4. Then I check if names position I, and as we know, I is represented by 0 in the first run, which is this position here. And I'm checking if it equals the target, so it's seeing if the input matches position 0. Okay. If it does, then I set the found variable to true. I also output this message saying name found at position I. And then I represents 0 at this moment in time, so it will say name found at position 0 if the name was Ali that was entered. Next I indicates we loop back round and go to number 1, so I goes up to 1, and we do the same thing again. And again, this will run until I equals 4. If found equals false at the end, what I've done is I've included an output statement which tells the user that the name was not found. The reason being is that the only time found changed was here. If the name was never found, then this if statement would never have been met and the found variable would have stayed false from the very beginning. So if that's the case and the if statement was never met in here, it simply would have went straight down and found would equal false, and in that way, name not found will be output. The questions are, what will be output if the user inputs chen? So obviously it will print out name found at position 0, 1, 2. So name found at position 2 will be output if the name chen is typed in. 1b, state what will be output if the user inputs Zara. And like we've just said, Zara is not in this list, so it would have output name not found. So this condition would have been met because found would have been set to false from the very beginning. Okay, so hopefully that makes sense. If not, give the video another watch and I'm sure it will sink in. And then finally, a bubble sort. And what I'm asking you to do is simply fill in the gaps to complete the bubble sort pseudocode. So we've got an array that contains 4 numbers and I've got a length which is set to 4. And I'm going to run a for loop from 1 to length minus 1. So it's going to be 4 minus 1. And again, we've discussed this in the lesson because we are checking a bubble, which means the first number is not included in the length. So we always need to minus 1 from the length, okay? Because the bubble will go from here to here to here. So we only actually need to loop 3 times in this case. So the loop inside, again, this time what I've done is I've put a for loop inside another for loop, and in this case what will happen is that the pass will minus 1, meaning that the loop will get shorter and shorter within each iteration of the outer loop. Okay, so this one is a little bit more confusing than the previous version, but it is an alternative way to write a bubble sort. So the missing lines are the key lines here, which I mentioned in the lesson, and I hope now you can realize what is missing from this. Now, I've not specifically mentioned in which order the numbers need to be, but we're just going to assume it means from smallest to largest. So what we're going to do is we're going to check if array I, so I equals 1, is more than array position I plus 1. Okay, so let me just zoom in. So if array I is bigger than array I plus 1. So this is the bubble here. It's checking these 2 values and hopefully we'll put them in order. Okay, so if this is true, then we go into this if statement. We store the number in the position I in a temporary variable, which is the first step of the swap. We then put the one from the position next to it, so I plus 1, into the position I. And then we need to put the temp variable into the position 1 to finalize the swap. So array position I plus 1 becomes temp. Spelled the same. Okay, and that's in squared brackets because it's indicating the position of the array. Okay, so I plus 1, that's an I plus 1, becomes temp, which was the number that is being swapped around. And remember, this only swaps around if the number was bigger than the next one, meaning it's not in the correct order. So there's the solution finalized. Again, I hope this all makes sense, guys. And if not, please give it a rewatch because this is very, very important for your paper 2 exam. Okay, simply by identifying these 2 algorithms, the linear search and the bubble sort, you may pick up marks for just simply saying what they are. And some questions even give you a trace table where you have to follow this algorithm, but by knowing it beforehand, you set yourself up to get the most amount of marks possible in these types of questions. Okay, so good luck. And any problems or questions, throw them in the comments, and I will see you in the next lesson.